Hi, I'm Audie Cash. Thank you for joining me. We're going to be doing a centralized system design where smartIAQ in a centralized form or side streams form will be used to clean return air to help us reduce outdoor air on this project. Now, in a centralized system, you do need a centralized or ducted return or open plenum return that allows us to layer in smartIAQ units to reduce your outdoor airflow. In this particular example, I'm going to be looking at an office space. First thing you're going to do is select your location. And then you're going to go down into this zone definition, and I'm going to choose office floor 2 as an example. You'll note it's unsaved, or as a reminder, you want to hit save once in a while because unsaved information, say if your browser were to collapse or crash, you'd lose all of your unsaved information. So it's important to hit save once in a while, and I'll do that in just a few minutes. You decide whether your system is a constant air volume or variable volume. Typical of an office space is variable volume. My outdoor airflow filter or my system filter is going to be a MERV 13. And I'm going to provide warm air at the ceiling. So I'm going to use a zero point 0.8 for my system ventilation effectiveness. And my air cleaning system is a centralized system. So I'm going to choose centralized. You'll note this window pops up here for the peak simultaneous occupancy. This is for occupant diversity calculations, which we'll use later. If you don't need to use this calculation, enter the same value here as you do for your default population. We'll come to that in a second. You'll notice we get to select multiple air cleaners because you can parallel smartIAQ units for larger air cleaning requirements. For now, let's get into the application. So first of all, let's do an open plan space. And we'll have this defined at approximately, well, first of all, we need to select office space, and we'll have it planned for about 9,000 square feet with 10-foot ceilings, and the default occupancy for 62.1 automatically drops in. Turns out we pack our space a little tighter, so I put 60 people in this space, and I have a supply air of 8,000 CFM as my design goal. And for outdoor airflow, I'm going to skip at this point because my ultimate objective is to save about 30% of outdoor air on this floor plate. I'm going to let the system do that for me. The next thing I need to do is add another room, and maybe I'll put this as a break room. And there's a break room option. Employee break rooms for offices are here. It's going to be a 600 square foot break room space, 10-foot ceilings, default occupancy is 30. I'm going to supply 600 CFM of air to that space. Again, I'm going to skip the outdoor airflow, and you'll notice over a few minutes that the V sub C will start to divide based on our application. As you add more airflow, you'll notice each time you add airflow, it divides the V sub C, or the clean airflow from smartIAQ, based on the ratio of supply air, which makes sense because our return air is being equally distributed to each space. Now, on my floor plate, I'm going to have a couple of boardrooms, or one boardroom and one meeting room. Let's say, for instance, boardroom. Let's have this as a meeting conference room. This is the bigger room of the two, so we'll set this at 3,500 square feet, 10-foot ceilings. Oh, let me select that space right there. The default occupancy for that big room is 175. That's a lot. I'm going to go ahead and set it to 150. The supply air will be 1 CFM per square foot. Again, I'm going to skip the outdoor airflow, and I'm going to add one more room here, meeting room 2. Let's call it a meeting room. Conference meeting. And it's going to be a 1,500 square foot space, 10-foot ceilings. Default occupancy, I'm going to make that, instead of 7550, supply air will be 1,500. And I think for fun, what I'm going to do is say we have another room just like it. We actually have a nice meeting room, another one just like it. Hit duplicate. It's exactly, we have duplicate spaces here, meeting room 2. And for now, maybe there's a lobby space. Let's add one more room. We'll call this, elevator lobby. So we have a lobby here. It's a 250 square foot lobby. 10. The default occupancy says 38 and 250 CFM. And so now, again, I'm not going to mess with the VOZ. I'm going to wait and come back to that. This will populate on its own. I'm going to hit Save Zone. Now that I've hit Save, I've laid out my office plate here. You'll notice the clean air rate has been divided equally among all the zones. And using the simplified procedure from 62.1, my E sub V, or my ventilation effectiveness for my system, is 0.75. Now, if I were to change, notice the peak occupancy by default is 375. Maybe I'll change this and go, you know what? It's unlikely that the office space will be fully populated at the same time as the break room, as the same time as the meeting room. So let's take a look at this. Say it's 378, let's say 300. Hit save zone, and it recalculates, and it still keeps E sub V at 0.075 because this ratio is greater than, as you can see right here, greater than zero point 0.6. Please reference 62.1 if you want some of those details. Now it's time to do the indoor air quality procedure. So I'm really curious about minimizing OA. That sounds interesting. But as I said before, my goal is to figure out to get to 60% of the VRP. I think that's what I said before. If not, we're going for 60 now and hit apply for all of these. So now I've distributed the outdoor air appropriately to get to 60%. So all of this got populated in that effort. And as you can see, with all of this work, this is a passing scenario. So all of my zones pass. So why don't we look at some of the details as an example. In this boardroom, all of my upper respiratory, eye irritant, and central nervous system tests are good. All the individual contaminants are very good. And I built a CO2 model, and it says, when this boardroom is fully occupied for more than closer to 4 hours, the CO2 could get up to 2,600 parts per million. That sounds a little bit high, but I could look at 62.1 and learn maybe what I'm interested in is 2,500, 2,250 as an example. I think I taught this in the other video, but I'm showing it again. So this tells me this needs 883 CFM for this particular room. I'm going to apply to system, lower it down. I can then close out of this window and I can hit saved room. So now my outdoor airflow for this room, the boardroom, is a little bit different than the rest of them. Now, what I ended up doing was taking air away. When I need to take some air away to make sure I still hit my goal here. So I'm going to make this 75 CFM, for instance. And I guess what I'm demonstrating here is that you can also individually allocate airflow if you wanted to. And again, this will have everything to do with the way you duct your system. All of these results that hit save, let's make sure everything passes. All of these results pass. And I'm complete. I can view my project summary. And of course, I can export. But before I do that, please click Configure and choose the smartIAQ side stream unit or the centralized unit that you want for your project. I'm going to use the one that supports BACnet MSTP, hit save, and now I can hit anything I want to customize for my columns. I can do that, and then I can hit export, and now I have a design fully saved and ready to go in Excel for my drawings.